So if we want to avoid the headache of recursion when dealing with our arithmetic sequences, we can get our general term, but it follows pretty basically from the sort of logic that we would have with recursion. That is, an is equal to a1, our initial term, plus n minus 1, so 1 less than the number we're going up to, times the common difference, d. Pretty basic, pretty straightforward. It's actually very, very similar in terms of the thought, like I said, to what you do with recursion, but let's see it in action with a couple of examples here. So for our first example, we want to find the sixth term in the arithmetic sequence with common difference -5 and initial term 8. So we have, for this example, n is going to be equal to 6, a1 is equal to 8, and d here is equal to -5. So if we want to find an, in this case a6, what we would do is take that initial term 8 and add to it 6 minus 1 multiplied by the common difference -5. So we would get 8, which would be plus 5 times -5, so minus 25, or that a6 is equal to -17. This is pretty basic stuff, so actually let's do one more quick example here where we look at it in more of an applied context. A bit more meat on it, as it were. So for this example, we have that the data in the graph show that in 2010, 5% of the US population was Asian. On average, this is projected to increase by approximately 0.1% per year. And what we want to do from here is write a formula for the nth term of the arithmetic sequence that describes the percentage of the US population that will be Asian n years after 2009, and to figure out what percentage of the US population is projected to be Asian using this model in 2025. Okay, a lot of words here, a lot that we need to be careful with, but what we can understand here comes from our notation. We can just house this in the language that we've been working from. So we have a1 is equal to 5, and because we are projecting that the population goes up by 4% over those 40 years, we are going to have that our common difference is 0.1%. So if we want to find an, we can just use that general formula. We would have 5 plus n minus 1 times 0.1, and usually we want to be a little bit more exacting than this. So we're going to multiply in that 0.1 and simplify. We'll get 0.1 times n plus 5 minus 1 times 0.1, or 5 minus 0.1, for 4.9. So if we want to get that last value, that projection in 2025, what we need to understand there is that 2025 is 16 years after 2009. Just think a little carefully with that. And that means we're looking for A16. So that would be 0.1 times 16 plus 4.9, or 1.6 plus 4.9, which is to say that in 2025, according to our model, we project that 6.5% of the US population will be Asian. Hello, a couple of quick words here from the editing room as I did a little bit more looking into this. The model here doesn't specify what it means by Asian American, whether that would include people of multiple ethnic backgrounds or what it specifically qualifies as Asian in this context, because sometimes people only refer to East Asians when they're talking about that, and it's a little bit more complex than just the number 5. Anyway, if we look at this as compared to US Census data in 2018, we'll see that the model here is not quite right anyway. If we talk about this as just being the percentage of the population that identifies as Asian American alone, that came in at about 5.4% in 2018, which would be a little bit below what the model would suggest at that time. Meanwhile, if we include people of multiple racial backgrounds, those are Asian and white, Asian and black, or 3 or more races, what have you, that number would come up to 6.5, which would then make our model a fairly significant underestimate. In any case, though, the percentage of the population that is Asian is a growing demographic in the United States, and one that is certainly deserving of more respect and less violence than it has seen in the last year, and in particular these last few weeks. But anyway, just a quick word from the real world here. Back to the video. And the last thing we're going to do with this section here is just a quick think ahead to the types of things we can do with these sequences. Because remember, I talked a little bit about series as being important. And so we're going to start looking at these things called partial sums, where we're talking about taking amounts of our sequence and adding it up to see if some nice patterns arise, which for these, we will actually get some interesting values.